So moving on to level 6.3, we're going to be talking about properties of trig functions. So this is going to be talking about finding exact values and then working with sine and cosine and figuring out what the value that they determine. So as we talked about before, and if you want to use your unit circle, that's a great reference. We've looked at all of the angles that are on the unit circle from 0 to 2 pi. And a lot of our focus is going to be talking about in radians. So here's our unit circle, 0, pi, and then if we go around, we go to 2 pi. If we go around a circle, we get all of the angles that we need. If we actually spin around more than once, so more than one revolution, so if we go around more than one revolution, we're still on the same circle. So we get to the same angles. So in the book, they usually say sine of x plus 2 pi is equal to sine of x. Likewise, cosine of x plus 2 pi is the same thing as cosine. So if we make a full spin around the circle, we still get back on to the same value. And as we said before, sine of x is equal to the y value over the radius. So in our case, with the unit circle, the radius is 1, so it's equal to the y value. And so cosine x is equal to the x value, or x coordinate, over the radius. So in our case, it's just the x value. So these two are for unit circle only. We'll see about that in just a second. So why do I go through all that explanation again? Well, to start with, A, when it says find the exact value, 17 pi over 4 is not on the unit circle, but we can put it on there, we can find the equivalent value. So what we do is we take 17 pi over 4 and we subtract 2 pi. And 2 pi for us is 8 pi over 4. So 17 pi over 4 minus 8 pi over 4 is 9 pi over 4. Well, we don't know what 9 pi over 4 is, so we subtract another 2 pi, or 8 pi over 4, and we get pi over 4. So sine of 17 pi over 4 is equivalent to saying, what is the sine of pi over 4? So now we look on our unit circle, and we see that at pi over 4, the y value is the square root of 2 over 2. So the sine of pi over 4 is equal to the square root of 2 over 2. And this number is our answer. So similar ways, we want to put this angle, sine of pi over 4, onto the unit circle. So we're going to subtract 2 pi. So 5 pi minus 2 pi, we get 3 pi. Still not on the unit circle. So if we subtract another 2 pi, we get pi. So what we're being asked is, what is the sine of pi? So again, if we look at the unit circle, what is the y value here? Well, just remember this is negative 1, 0. This is 1, 0, x, y values. So this is 0. For C, for tangent, 5 pi over 4 is on the unit circle. That is this angle right here. And if we remember from before, we have all students take calculus. And just as a refresher, this means x and y are both positive. Sine's positive in the second quadrant. 1, 2, 3, 4. Tangent's positive in the third quadrant, and cosine's positive in the fourth quadrant. So the tangent of 5 pi over 4 is the square root of 2 over 2, negative, divided by the negative square root of 2 over 2, which is just 1. Because a negative divided by a negative is a positive. So that's what we mean by find the exact value. We could ask similar questions. So 2 says, if the sine is negative, so another way of saying that, if the y value is less than 0, and the x value is less than 0, because sine goes with y, cosine goes with x, which quadrant is the angle in? Okay, so which quadrant are both the x and y values negative? Well, if we just look up here, We want the y values negative, so we're below. We want the x value negative. So that is quadrant number 3. And that's all that question asks. So example 3. Given sine theta is root 5 over 5, and cosine theta is 2 root 5 over 5. Find the exact values of the 4 remaining trig functions. So we need to find tangent. We need to find cosecant. We need to find secant. And we need to find cotangent. Tangent, in our case, is sine over cosine, or the y over the x. So we take root 5 over 5 divided by 2 root 5 over 5, which if we do the algebra here, these cancel, we're left with 1/2. The cosecant, remember, is 1 over the sine value. So we have 5 over the square root of 5. Now, just for our sake, we can rationalize this, so multiply the top and bottom by root 5. So we have 5 square root 5 over 5, or the square root of 5. I'm going to do a different color. So secant, same thing, is 1 over cosine theta. So 5 over 2 root 5. And if you see, we're going to do the exact same thing as above. So we're going to top and bottom by root 5. We're going to get root 5 over 2. Lastly, cotangent is 1 over tangent theta. And we already found tangent, so that saves us a lot of work. That is just 1 over 1/2, or 2. So if we are given the sine and the cosine, it's super easy to find tangent, secant, cosecant, and cotangent. What if they only give us one angle? So we have to draw a triangle from this. Any of these questions, when they say, given a sine value and a quadrant, we're going to have to draw a triangle in standard position. So you might be thinking, well, what is standard position? And we learned that in 6.1. We just start from, so we're going to draw a quadrant, xy coordinate plane. Sine is 1 over 3, so that means my y is 1, our up is 1, and our hypotenuse is 3, and cosine is negative. So if sine is positive and cosine's negative, that means we're in the second quadrant, because I want a positive y and a negative x. So now, in order to figure this out, we're going to have to do the Pythagorean theorem. So we're going to call that x. We have x squared plus 1 squared equals 3 squared. So x squared equals 8. X equals 2 root 2. And it's negative because it's in the second quadrant. So our x value is negative 2 root 2. So it says find the exact value of the remaining trig functions. So we can say cosine theta is negative 2 root 2 over 3. We can say tangent theta is equal to opposite 1 over negative 2 root 2. And if we rationalize that, we get root 2 over negative 4. If we want to find cosecant, then we have, we already have sine over there, so it's just 1 over 1/3, which is 3. I'm going to do blue for the other colors. So we have cosecant. Secant is just the reciprocal of cosine, so we have negative 3 over 2 root 2, or negative 3 root 2 over 4. And then we need cosine, tangent, cosecant, secant, and cotangent. So cotangent is just 1 over 1 over negative 2 root 2, which means it's just negative 2 root 2. So these are types of the questions that we're going to be working with properties of trig functions. Flip it over, we'll finish up this section. All right, so example 5. We know that the tangent is positive because we have tangent of theta equals 1/2. So tan positive, and we have sine negative. Well, the only place that tangent is positive is the third quadrant. So that gives us our starting off point. So we're going to draw our coordinate, and we're going to draw our angle in the third quadrant, and then we're going to make it a triangle. So we know that tangent, which is opposite over adjacent, so this is our angle, which I didn't point out in the first one, but this is our angle we're looking at, is opposite, 1, over adjacent, 2. But since this is in the third quadrant, these are both negative. So then we're missing one side. We're going to do 1 squared plus 2 squared equals h squared for our hypotenuse. So we have 1 plus 4, it's h squared, or h equals the square root of 5. So we have all of this information now that we need in order to figure out this triangle. So we have sine theta is opposite over hypotenuse, or negative root 5 over 5. We have cosine, which is adjacent over hypotenuse, which is negative 2 over the square root of 5, or negative 2 root 5 over 5. We already were given tangent, which is 1/2. So then cosecant, the reciprocal of sine, is negative root 5 reciprocal. Secant, which is the reciprocal of cosine, which is root 5 over 2, negative root 5 over 2. And cotangent, the reciprocal of tangent, is just 2. Okay. A couple other things that I want to point out. Basic trig identities. So this is our first time seeing these. We will be using these a lot throughout the next month, but some things I want you to be aware of. So these 3 Pythagorean identities come from knowing facts about Pythagorean theorem and then applying them to sine and cosine. So we know sine squared plus cosine squared equals 1. We also know that tangent squared plus 1 equals secant squared, and 1 plus cotangent squared equals cosecant squared. We will be working with these later on. But what should sound familiar to us is the even and odd properties of sine and cosine and tangent. So what I want to make apparent to you, so sine and tangent are odd functions, which means they're symmetric about the origin. We've done that since level 2. Cosine is an even function, which means that it's symmetric about the x-axis. So when you plug in a negative angle to sine, it's the same thing as taking the negative sine of that value. Same thing with tangent. If we have a negative, plug in a negative angle, which means we're going clockwise instead of counterclockwise, then it's just the same thing as the negative tangent of that. And because cosine is even, if we plug in a negative angle, it just takes away the negative, just like if we plugged in a negative to an x squared. So let's try some of that out, and then we are done with 6.3. So example 6, find the exact value of sine of negative 45. Well, since we know that sine is odd, this is the same thing as negative sine of 45 degrees. Sine of 45 degrees is the square root of 2 over 2, and we make that negative. So negative root 2 over 2. B, we know that cosine is even, so if we plug in a negative, that's the equivalent of saying, what's the cosine of pi? So then we look at our unit circle, we see that cosine of pi is negative 1, and we're good. Cotangent of negative 3 pi over 2. Well, if tangent is an odd function, cotangent, the reciprocal, is also odd. So this would just be the same thing as the cotangent of the negative cotangent of 3 pi over 2. Well, tangent of 3 pi over 2 is y over x, which is 1 over 0. So cotangent would be 0 over 1 negative, which is just 0. Lastly, tangent of negative 37 pi over 4. Well, that's not on the unit circle, but this is the same thing as the negative tangent of 37 pi over 4. Now I'm going to look for multiples of 8, and I can subtract 32 pi over 4, because that's 8 times 4, which is 4 revolutions. So if I do that, this is the same thing as the negative tangent of 37 minus 32 is 5 pi over 4. 5 pi over 4 is on the unit circle. I know what that is. That is positive 1, and I'm just going to make that negative. So try these problems out. Let me know how it goes.